All right, let's do some properties of Laplace transforms. So, given that the Laplace transform on little f of t is capital F for s greater than a, and if the Laplace transform on little g of t of s is big G of s, where s is greater than b, so they may have different values here, then the Laplace transform on some constant times f of t plus some other constant of g of t will be that constant times big F plus the constant times big G, and your S will now be greater than the maximum of these two values. Another property says the Laplace transform on e to the ct times f of t. So f will be some other function of t, and times e to some number times t, it'll end up being capital F of s minus c, where s will be greater than a plus c. The Laplace transform on the integral of from 0 to t of f u du, f of u du, it'll end up being 1 over s times big F of s, where s will be the maximum of a or 0. The Laplace transform on t to some exponent times some function of t will end up being -1 to the n, the nth derivative of big F with respect to s, if that same derivative there. And that's for s will be greater than a. We have the Laplace transform on q of t is equal to e to the negative cs times big F of s for s greater than a. What you're now going, where the heck did q come in, right? Well, q of t is this piecewise function of it's 0 when t is between 0 and c, and f of t minus c for when t is greater than c. And last but not least, the last little property we've got is the Laplace transform on the nth derivative of f is equal to this whole thing, right, where it's s to the power of n times big F of s minus s n minus 1 f of, times f of 0 times or minus s to the power of n minus 2 times f prime. You go all the way down until subtracting each of them until it's 1 less there of the derivative on 0, where s will be the maximum, greater than the maximum of a or 0. Okay, so let's do these. You want to have these on your little cheat sheet, right, for the final. We're going to find the Laplace transforms of these. Your textbook also has a list of Laplace transforms. Let's show you that too. If you want like just a cheat sheet of, this is page 435. You've got a table of transforms that you could refer to. Yeah, that'll be a good thing to put on your cheat sheet as well. All right, so let's find the Laplace transform of e to the negative t times cosine of 2t. All right, so if you look at your list, and do you see a pattern of something? Keep in mind, cosine of 2t is some function of t. Yeah. So this is some function of t. And do you see that if on this one, if you let c equal -1, do you see that it's property B? So this is property B, which means that it's equal to big F of s minus c. Yeah? Well, keep in mind that your f of t is cosine of at. When it's equal to that, do you remember that the Laplace transform of this is s over s squared plus a squared? So that means cosine of 2t, no, if f of t is cosine of 2t, well then big F, the Laplace transform on that guy, would be s over s squared plus 2 squared, or 4. Yeah? All right, so we want, but our c here is -1, so I want big F of s minus -1, so that means I'm doing s plus 1 into this guy. That means that it's going to be s plus 1 over s plus 1 quantity squared plus 4. Do-do-do! All right, let's look at another one. This one is find the Laplace transform of t cubed times e to the 4t. All right, so you look through there and you're like, okay, which property could you use? You definitely could use property B again, or the other one it matches is property D. You could do either property B or D. But on first glance, I don't know about you, here I'd have to take the third derivative, right, of this guy. So I think B is easier. Hopefully you see that, yeah? All right, so that means that this is going to be big F of S minus C, where, again, here your C is 4, and I'm going to let F of T be T cubed. And you remember from the other lesson that if F of T is T to the N, then big F of S was N factorial over S to the power of N plus 1. So that means that if your F of T is T cubed, well then we've got that this is, your N is 3, so 3 factorial over S to the 4th, which 3 factorial is just 6. And so our answer, so now this guy will be big F of S minus, your C now is 4. So you're going to have 3 factorial over S minus 4 to the 4th, which is just 6 over S minus 4 to the 4th. Good. All right, let's do another one. How about the Laplace transform of t squared cosine of t? All right, so this time, you don't have an E, so you can't use property B this time. This time, it really is property D, t to the power times some function, right? So this is going to be property D that we're going to use, where here your n is 2, t to the n, and then cosine of t is your f of t. And that property said, property D says it's -1 to the nth power, the nth derivative of big F of S with respect to S, right? When, yeah. All right, so your n here is 2, so that means that this is going to equal -1 squared, and we're going to take the second derivative of big F of S with respect to S twice. Yeah. All right, well, your F of T is cosine of T, and from the other day we had that meant that big F is S over S squared plus whatever number is in front of the T squared, so 1. So that means that I've got that this up here. Okay. This is going to be a positive now. Second derivative, so that means I need the this up here. I'm going to be taking the the second derivative of, with respect to s, of s over s squared plus 1. Now, I just didn't want to write that whole thing again. Okay, so we'll come over here. And what's the second derivative? Well, you're going to have to use quotient rule. Right? So I'll take the first derivative first. So I'll do it twice, right? Which means take the bottom. So I'm taking the first derivative now, times the derivative of the top. This is with respect to s, so it's a 1, minus the top times the derivative of the bottom, which would be a 2s, and then all over the bottom squared. Okay. Let's clean this up before we take the derivative of this guy again. So this will still be, remember, we're taking second derivative, so I did the first derivative first, so I still have this out here. So that's what? S squared plus 1 minus 2s squared all over s squared plus 1 quantity squared. Well, that means that up top here is just 1 minus s squared over s squared plus 1 quantity squared. Oof. Okay, we can do this. Quotient rule again, where you take the bottom, so it's the bottom, times the derivative of the top, which would be 0 minus 2s, minus the top times the derivative of the bottom. Okay, well, that would be a pop and drop, so a 2 times s squared plus 1, now to the power of 1. But then chain rule would say go inside there and take the derivative of the inside, which would be a 2s. Now, and that's all over the bottom squared. So s squared plus 1 squared squared, so to the 4th. Maybe I should write it twice. Count like that. Squared and then squared. Okay. So then let's clean this up. You know what I think would be the easiest is, because I see factors that are in common between here and here. So rather than multiplying them all out and then cleaning it up, I noticed that there is a negative 2s in common to both terms, right? I'm going to factor it out. I also have an s squared plus 1 to the power of 1 in common to both of these terms. So I'm going to factor those out. When I do, the first term, I would still have 1 more s squared plus 1. And then I factored out this minus sign with this guy. So now it's a plus. And then it would be a 1 minus s squared and then times a 2. Yeah. All over s squared plus 1 to the 4th. Okay, well, when you clean that up, I still have the negative 2s. I have an s squared plus 1 here. I have a s squared plus 1 minus 2s squared. So what is that, a 2? No, a 3, because it's a 1 plus a 2. So a 3 minus s squared. Hopefully you see that when you clean that up in there. We are almost done. Yeah? You see that this one on top will cancel with one of them on the bottom. And so your answer ends up being a negative 2s times 3 minus s squared all over s squared plus 1 quantity cubed. That was a lot of algebra. Yeah. That's right. Okay, let's do another one. Let's find the Laplace transform of t times sine of 2t. Okay, t times sine of 2t. Well, sine of 2t will be f of t. So this is another property d. All right, so property D, where here your n would be 1, and this is going to be f of t. Yeah? And so if f of t is sine of 2t, or here, if it was at, do you remember from the other day, when little f was sine of at, then big F was a over s squared plus a squared. Now, cosine has s on top, sine has a on top. All right, so that means if f of t is sine of 2t, well then big F will be, your a is 2 this time, so 2 over s squared plus 4. Okay, so that means that this guy will equal -1 to the nth power times the first derivative with respect to s of your big F of s. So 2 over s squared plus 4. I think instead of doing the quotient rule, I mean, you could, I would do it as, okay, this is a -1 times the derivative of, how about 2 times s squared plus 4 to the -1 power? And then I can do product rule, or I don't even have to do product rule, it's pop and drop, right? So I've got a -1 in front. Taking the derivative of this guy would be a -2 times s squared plus 4 to the -2 power now. And then times, chain rule would say times the 2s. Looking good. All right. You got a negative, and a negative makes it positive. A 2 times 2s is a 4s. So this becomes a 4s over s squared plus 4 quantity squared. Yeah, because that -2 power goes downstairs. All right. How about, let's find the, we're going to do one on an integral. Let's find the Laplace transform of the integral of 0 to t of cosine of 5u du. All right, so the cosine of 5u du is fu du. It's definitely property C, right? Where it'll equal 1 over big F of s. So this will equal 1 over s big F of s, knowing that this is property C that we're using, and this guy is F of u. All right, so if you remember that when F of t was cosine of at, then big F was s over s squared plus a squared. So that means in this case, it's going to be s over s squared plus 5 squared, so 25. So that means that this guy, so the 1 over s times f of s will be 1 over s times s over s squared plus 25. Well, your s's cancel, and you're just left with a 1 over s squared plus 25. Not too bad. Huh? All right, let's do a piecewise one. How about if q of t is equal to 0 for when t is between 0 and pi, but then it's equal to cosine of t minus pi when t is greater than pi. Okay, so this is property E, obviously, that says, oh, this Laplace transform, when it's a piecewise function like this, it'll be e to the negative cs times big F of s. So it'll end up equaling, so the Laplace transform of q of t will end up equaling e to the negative cs times big F of S. All right, so and looking at that, remember that this is C. The pi is C. If you look back at this thing, you're looking at if the second guy is the function of f from f of t minus c, where t is greater than c, and here from 0 to c. So your c is pi in this problem. And so that means that, I should have written that over here. And then do you remember if you've got, so remember that if it's cosine of t, then big F of s is s over s squared plus 1. Yeah. And so your Laplace transform, keep in mind, you've got t minus c here, but yet it ends up being just f of s there. So you end up with that this is equal to e to the negative pi s times s over s squared plus 1. And you are done. It's a lot of like matching up the pattern and stuff, right? All right, let's do one more. And that is to find the Laplace transform on the third derivative of t, given that f of 0 is -2, f prime of 0 is 0, and the second derivative is 1. Okay, so here we go. We're going to use the property f. Yeah, property f says if it's the nth derivative of t here, then you'll start off with s to the n, big F of s. Okay, so that's what I'm going to use. All right, so that means if it's a 3 that I'm plugging into the n here. So this Laplace transform of the third derivative, so that means your n is 3 there. Plugging it into property f. Yeah. Okay, so that means that it's going to equal S3 times big F of S minus S squared times little f of 0 minus s to the power of 1 times the first derivative of f at 0, and then minus the second derivative at 0. You go all the way down to 1 less than this degree. Okay, so that means I'm going to have s cubed times capital F of s minus s squared times -2 minus s times 0 times, right? Because that was to the power of 1, and then minus 1. And so that just leaves you with s cubed times big F of s. That makes it a plus 2s squared. The 0 goes away, bye-bye, and then a minus 1. And there you go. Those are the properties of the Laplace transform. We're working our way. We got this. All right. Have a good day. Bye.